The purpose of this video tutorial is to show an example of setting up an elevated slab with the use of Dramix fibers. So we're going to launch Builder. We'll go to this pull down arrow. Make sure that we have Floor Pro selected. In order to model an elevated slab and to set the fiber design type as an elevated slab, we need to make sure Floor Pro is selected. This will be set up as PTRC that we could either add post-tensioning or not. That can be done in combination with fiber. So we'll use this option, but we're not going to add PT for the first model we'll look at. And we're going to go ahead and use US units. I'll select OK. And we're just going to use the wizard to set up the model. So we'll go to Model, Floor Wizard, and we're going to do 3 by 3 spans. These will be 30 feet. Now the columns will be 20 by 20 inches, and the slab thickness we'll say will be 6.5 inches. And then 6.5, and then the loading will be 20 and 50 PSF for superimposed dead and live load. We'll turn off the option for post-tensioning for now and go ahead and create our slab. And I'm going to go ahead and save this. Okay. You'll notice if I double click, I'll go to the default display and then double click on the slab. The default display just turns the loading off. The loading was on top of the slab, so had I double clicked, it would have opened the loading input. Here you can see the default is Concrete 1, which will kind of be our control model. So we're going to leave this as is for now. I will make a change. I'll go back to Concrete, and I'm actually going to change this to 5,000 PSI Concrete. We'll go to Analysis. We're going to mesh the structure. Under Criteria, I'm going to make sure that I have the ACI code selected. We use ACI 2014. And also under the Analysis and Design options here, we're going to turn off the option to include minimum rebar. So we're just going to focus solely on rebar required for strength. The program obviously can check and add minimum rebar. We're going to ignore that for now. So we'll turn that off. I'll go over to Load Combos, and I'm going to eliminate the service combos. We'll just focus on just strength, dead, and live. So we have a gravity load combination essentially that we're going to look at, and we'll say OK. Okay, we'll go ahead and analyze. And then I'll go over to floor design. I'll go back to default display just to remove the shell elements from view. And I have X and Y support lines. So I have both directions. I'll go ahead and generate the design cuts. And it's telling me that there's one location that has not enough design cuts, and you can see where that occurs. So let's go ahead and I'm just going to take this support line and stretch it out. And I'll do the same thing here, move that one out. And I'll do that on both ends. And then we'll do the third one right there. The one on the far left should be okay. I'll go back to generate the sections, and now we have sections that are okay. So we have our Y direction and then our X direction. Okay, we're going to design the section cuts now. And we're going to just look at one of these end spans on an interior strip. You can see here that the moment demand at this location, the peak moment, is 285.6 kip feet. So if I double click on that section, the moment capacity is right at 288.7. And if we look at the rebar, we need 13.8 square inches of steel at that design cut to satisfy the moment, 285.6. And you can see if we generate rebar for either envelope or just for strength, we have quite a bit of rebar there. We have 18 number 8 bars, which is a lot of rebar. So also, if we were to check punching shear, let me just go back to default display, and under floor design, I'll go ahead and execute the punching shear check. You can see that most of these exceed code. They exceed the maximum allowable shear stress around the periphery for the first critical section. And here in the middle, we're right around, hovering around 2 as our, a little over 2 for the demand capacity ratio for punching. So we have that code that's shown. So now what we want to do is we're going to change this to include fiber. So what I'll do is I'll go back to criteria. I'll go to still fiber. I'm going to add Dramix fiber. And for Dramix fiber, I want to make this also 5,000. And then we're going to set the design type to elevated. I'll set the fiber type to 5D 65/60. And then I'm going to include the minimum amount within that spec for the fiber type for my dosage, which is 42 pounds per cubic yard. For the size factor, the program will either auto-calculate based on the design type. So, for example, the setting is 1 for slabs on ground, slabs on piles, or mats. The only applicable design type in that group is a slab on pile, or for members with a cross-sectional area of 36 square inches or larger, where you have a specific type of FRC matrix. Otherwise, the program will calculate it really based on the degree of static indeterminacy. So we're going to use the auto-calculate option. This should be close to 1 for this particular slab. The structural use factor for a structural slab in this case will be 0.85, and then we have our strength reduction factors for flexure and shear when fiber is used. We'll leave those as they are. We'll select OK. We'll go back to our slab, and we're going to change this to concrete 2F, and this will show us what the type of fiber, the design type, dosage, and whether or not we're considering nonlinear. Nonlinear is actually not available for elevated slabs in this case. So now that we've done that, we're going to reanalyze the system. We'll go back to analysis and execute the analysis. Okay, and then we'll go over here to floor design, and instead of designing, we're actually going to investigate the sections. Earlier, when we looked at the capacity with the extra rebar, the 13.8 square inches of rebar that we needed, the capacity was 288.7 kip feet. And if we look and investigate the capacity of these particular strips with fiber only, I can do that by selecting the moment capacity option here. And we can see at that same location our capacity is right around 97.36 kip feet. And if we double click, we could also see it's around 97 kip feet here. The demand is still, roughly 270 to 280. I think this was the highest demand requirement here. So now what we'll do is go ahead and just design that strip. So I want to design the strip. If we zoom into this, we can see that the capacity is now 288. We're designing just to the point at which we have an exceedance of MU, which is again 285. If I double click here though, with the addition of the fiber, the required still has gone down to 9.2%. So originally we had 13.8%, and this has gone down roughly around 33% in terms of the required amount of steel with the addition of fiber. In addition to that, if we go back, and I'll go back to my default display, and I will check punching again, we can see that the code is still exceeded, but we've gone down by roughly 50% in terms of the demand capacity. So while we still might need to thicken the slab in these locations, we still are at a point where we would have less reinforcement with the thickening than we would otherwise without fiber, with thickenings as well. So you can see there's clearly a difference in the capacity of the slab with fiber for shear and also with fiber for flexure. If you have any questions, please contact us at support@adaptsoft.com. Thank you.